We have now all the necessary action for our robot, and we are going to start building our bot controller. The first thing that we need to have is access to variable that are going to allow us to control these actions. So what I'm going to do, I am going to jump to the coding layout. And here with my library selected and my MicroBots directory selected, I am going to create a new controller, asset and new controller, and I'm going to call that controller bot controller. This is going to be the action controller that we're going to use to blend our different animation actions together. Make sure that the library can visualize bot controller. And since I'm going to bounce between the two editor, the code editor and the controller editor, I am going to pop a controller editor right here. Now I am going to drag and drop my asset so it is in edit mode. And the first thing that I need to do is to connect the actual skeleton, which is the bot controller object. So I am going to click and I am going to select my bot controller object, which is the skeleton connected to my bot here. I am going to create a new layer. I'm going to select it. And for my entry point, I'm going to create a single entry here, and the motion will be idle. So I start this controller state with idle, and next I want to move to a 2D so I can interpolate between the action forward and back, left and right. So I'm going to go on add the new clip and a blend 2D here. And in order to drive this new action clip, I am going to need to have two variables. One that is going to control my x-axis and the other one that is going to control my y-axis. So I am going to click here and enter variable editing. I'm going to add a new variable of the type float, and I am going to access the variable properties and call it axis x. And axis x should be from the range of -1 to 1. I am going to repeat the same process, float, and this time is going to be for axis y, and this also will be in the range of -1 to 1. And on top of that, our robot, both controlled by the player and or controlled by the AI, will require us to have a health and ammunition. So we are going to create two more variables. The first one is going to be an integer, and we're going to call it health. And let's say that the range is from 0 to 100 to give us a default value. And now we're going to need to have ammo. So add new variable integer, and this one will be ammo. And this is going to be the default health and ammo value that each and every robot will basically have when they get started. So we are now having our axis X and Y, and on top of that, we're having health and ammo. If we go back here, we are going to now be able to connect our two variables. Our variable X will be axis X, our variable Y will be axis Y, and now we are going to be able to start adding different action. Instead of using the method Cartesian, I'm going to use radial. That is going to give us a smoother interpolation range. So I am basically going to add 4 action here. 1, 2, 3, 4. And since the robot is actually facing down the y-axis, we are going to need to invert things a bit. So left and right will be inverted, as well as forward and back. We could have always changed that in Blender, but just to keep the direction where the actual bot is looking, we are simply going to code it that way. So my first one will be positive X. That is going to be my left action. Then negative 1 will be my right action. And following that same sequence on the Y, -1 will be my forward, and 1 will be backward here. So I have now my action, my 2D action set up, and I need to start creating a state that is going to allow me to jump, a transition that is going to allow me to jump from my entry state to my action. And just to be more clear, I'm going to hold Control, drag and drop, and I'm going to call this block action here and resize a bit. And like that, I'm going to create my first transition that is going to go from my entry state to my 2D action clip. I'm going to push spacebar to create a new transition. Clicking on that transition, I am going to go under variable, and what I want is to have an immediate transition. As soon as the condition that we're going to set here is true, we are going to jump directly regardless of the current playback time of our idle animation. So I am going to enable here to have an immediate transition, and the duration, I'm going to put something like 0.25, just, to get us started, which should be a good value. We are going to start with a true equality, and we are going to basically add 2 conditions here. So our first condition will be on the x-axis. And what we want is if the x-axis is not equal to 0 and our y-axis is not equal to 0 as well. And what we want is to have them as a inclusion. So we are going to click the and here. So our condition is true if we have our axis x that is not equal to 0 or our axis y that is not equal to 0. If it's the case, we're going to directly jump over here. Now we need to do the process the other way. We are going to select our 2D blend action clip and holding shift our entry state, hit the space bar, and we have now a transition coming from here to this side of the graph. So selecting the transition, we are going to repeat the process. We want also to have an immediate transition, and we want the duration to be 0.25. And this time, we are going to leave the equality to false. We are going to add 2 new condition here. And this time is going to be if our axis x is equal to 0 and our axis y is also equal to 0, and we want them to be inclusive. So I am going to click. Now we're going the other way around. So we are going to click the inclusion on our y-axis here. So with that set up, we are now ready to test on our robot. So we are going to make sure that our robot is selected. I'm going to type in bot here, and I am going to go under object properties, and I am going to add a new action controller, and I'm going to open this up. And I am going to simply drag and drop my controller here. Now I need to be able to synchronize those variables to my current object. So I'm going to hit the little button here that is going to synchronize my variable. And if I drag all the way down into member variable, I am having basically an exact copy of the variables that have been declared for in my action controller here. Now, to have it triggered, I'm going to push play here to increase the application time. We can see that our bot here enter the idle state. And if I move the x-axis on the left or the right, I am going to see that I am I'm switching between the action here. Of course, now I am manipulating that manually, so it's a bit rough. We are going to smooth that when we are going to actually implement the real control. And as we are going backward, we are going forward. Everything seems to work properly. There's only one state that we need to handle now, and is going to be when the robot is actually dying. So what we're going to do here, we're going to go back and we are going to add a new action clip of the type any state. So at any point in time, if our health reach 0, we want to play the death animation. So any state, and we're going to add a new action clip of the type single. And I am now going to connect from any state to this one here, which will be the action death. And I am going to hit spacebar to create a transition. Here and there, push spacebar. I got my transition. I want to have immediate transition. So I'm going to select it first, go back on variable, enable immediate transition. I want a transition duration to be 0.25. And for my condition is going to be very straightforward. If my health is, let's say, less than 1, then we are going to run forever and ever the death animation, and that's going to end our state unless the action controller is restarted. So we can test that right now. If we are in this state, I'm going to put 0 here, and our guy just simply die and keep, just continue running that death animation. And in code later on, we're going to reset the action controller, which will bring us back to the entry state, and so on and so on. So basically, we have now our action controller that is fully set up. Let me stop that here. We have our action controller that is fully set up, and our object also have member variable that we can now start playing with. Let me restart that at 100 here. And we have now a variable that we can start coding with. What we want now is to actually put the boots of that robot on the ground. We could probably use the terrain geometry as it is for a collision map, but I always found it better to have a dedicated geometry to use as a collision map, as it is more optimized. So we are going to go back into Blender, and we are going to toggle off the visibility of the bot action collection and open up maps. And under maps, we basically have two maps. We have an occlusion map and a collision map. We're going to focus our effort for now on the collision map. So I am going to select the object, and I am going to go under File, Export, and Collada. I'm going to overwrite my MicroBot file and ensure that in the main tab, selection only is selected. Export. Back to my NRG editor, I am going to quickly jump to my default layout. And I'm going to select the MicroBots directory, and I'm going to go under Asset, Import, and import that collision map. Open that up. I am only interested in the geometry. I do not want any materials, any animation, no skeletons. I don't even want to create an object and place it on any render layer, so I'm going to turn everything off. I'm simply going to import the geometry as it is. And under MicroBots Mesh, I am going to type in COLL for collision, and I'm simply going to drag and drop the geometry on my viewport. With my new object selected, I am going to rename it to be collision map here. And I am also going to zero out the location, and it is rotated at 90 degrees. So I'm going to add 90 degree here. And like that, if I enter wireframe by pressing tab, I can see that it is laid out on top of my actual level geometry here, which is exactly what I want. I'm going to later on be able to reuse that collision map to create the navigation map for our non-player character. But for now, we're going to simply use it to determine where the player can and cannot go. So we are going to go, I'm going to turn off here the pivot point. So I'm going to go under Properties and Scene, drag all the way down. And in debug mode, miscellaneous drawing, I'm going to turn that off. And also I'm going to change the actual clear color here because it clashed with the wireframe color. So I'm going to jump quickly under code, and then I'm going to go under renderer, geometry, and the geometry script. And I'm going to change the clear color here to be something more friendly. Let's set that to 0.5, which is going to give us a mid-gray. Rebuild that. Quickly jump back to our default layout. And with my collision map selected, I'm going to go under Properties and Physics, add Physics, Static Object, and add Collider, and a simple triangle mesh. And like that, I'm having all my collision map from a world physics standpoint that is created. I do not need this object on my render layer here. I'm simply going to turn it off and keep only the visualization of my collision map. Now we're going to focus on our robot, which is dead over here. I select it and push the dot or delete del on the numpad to put the focus on him. And I am going to simply give him a little boost by restarting the action controller, pressing play and stop. And what I want to do now is I'm going to go under my outliner and I'm going to type bot. And we can see that the bot is actually connected to an empty object, which is the bot controller here. If we check the transformation of that bot controller, that empty object, it is scaled very, very small. We are going to basically invert that. We're going to put the rotation, the 90-degree rotation on the robot itself, as well as its scale of 0.01. So what I'm going to do is and also I don't want this object to be static. This is basically the empty object that I'm going to use to add a capsule collider. So my robot can move around the collision map. So I'm going to toggle that off to make sure that it is not static. and I am going to reset back the rotation and set the scale to 1. Our robot is now really, really big. And I'm going to select the robot this time, and I am going to give it a rotation of 90 and set back the scale to be at 0.01 on the X, on the Y, 0.01, and on the Z. So it is back in place, and now I have my empty object that is easier to select and easier to manipulate. What I'm going to want first is to create a capsule collider around my empty object. So I'm going to go under Properties and Physics, add Physics. This time I want a rigid body, and I want to add a collider of the type capsule. And I also going to give it a mass of 74 here. And I also do not want this capsule to bank. I want to strictly have dynamic physics. I want my capsule to stay straight up. So I'm going to go under Factors and Angular, and I'm going to turn the angular factor X, Y, and Z to 0. So like that, only the linear velocity will actually kick in, and all the other angular factor will be set to 0. So my capsule will always stay straight at all time. So I'm going to now set the actual size of my capsule, which is going to be something like 0.9 and 0.3. Which should give me a good value to get started. And now, as you can see, my robot is not really centered. So what I'm going to do is I am simply going to, I can either do that using the transformation here, or I can simply create a constraint. So I'm going to go under Properties and Constraint, add a new constraint. And what I'm looking for is Offset Location. Open that up and slightly drag down using the Shift button to ensure that our robot is pretty much in the center of that capsule, something like that, minus, I would say 0.75, let's say. Let's get started with that. We're going to check if the boot actually touched the ground. And now we have basically our physics that is set up for the robot. I am simply going to drag that down a bit, and we are going to test how our bot is reacting when the physics is on. I am going to pop a timeline here, and I'm going to ensure that this is toggled on, which not only, as we push play here to simulate the application time, we need also to simulate and increase the physics time. So this is what this button will allow us to do. So I am going to now push play and see how my capsule is behaving. It seems to be behaving properly. I'm going to push stop on that and push back tab to enter wireframe and solid. And I want to make sure that the boot of my robot actually touched the ground. I'm pretty far off here. So I'm going to select back my robot and keep dragging down until I start seeing that the feet start to kind of melt with the ground, which should be somewhere around here, minus 960. That seems to be giving good result. So basically now we have the physics that is set up for our robot, and now we can move on to the next step. Since we have been dealing with physics, let's finish the job. We are going to add physics on the crate object that later on will be duplicated and placed around our level. So I am going to select my first crate, which is the ammo crate. I'm going to go under Properties and Object. I am going to ensure that it is not a sticky or static object by clicking this off. Repeat the process for my health crate as well, because I want them to move in the world. I am going to select them both and place them in range near the ground. That's where I'm going to need them to be later on. So I can just duplicate and using the grab button, place them around my level easily. So I'm going to focus on them, bring them closer. And basically what I want to do is to simply create a box that is a kinematic box as it at runtime. I want these crate to go up and down and rotate. So I am going to need to have physics on them to actually detect the contact of my robot with the crate, but I will handle the transformation myself And I also do not want them to respond to contact. I simply want to detect the contact, but I don't want them to respond to the contact. So to do that, I am going to select my first crate, go under Properties and Physics, add Physics, Rigid Body. I am going to add a collider of the type box, and all the way down. If I switch to wireframe, we can see it here. And we are going to go all the way down, and I want to enable kinematic, and I want to disable contact response. I am going to repeat the same process for my other crate. Add rigid body, add a collider of the type box, scroll all the way down, kinematic object, and disable contact response. So basically, that's all there is to it. That is going to be the setup that we're going to use for our item crates here. Now let's start creating our first person camera. To do that, I am going to select the geometry object here. And what I want is basically to create an elliptic constraint that is going to place my camera right on top of the head of my robot and follow the bone of the head. So like that, as my robot is animated and run into the world, is going to basically, the animation will make the head go up and down, and is going to give the illusion to the camera that it is actually really running and walking and running in the world. So I am going to select my geometry camera, and I am going to go under Properties and Constraint. And the only thing I have to do is to create a elliptic constraint. The target will be my bot, and the target bone will be his head here. And I am going to give it a little offset. Let's say minus 0.1. And that is basically going to allow me to follow my robot head at all time. I can now create another constraint that is going to force the camera to target that bone. So it's always going to look down in front of where the robot is going. So I'm going to add constraint, track target, open that up. Target is going to be once again my bot, and the target bone will be its head. And like that, we are going to have a full first person camera that is going to be actually usable. And as I push spacebar to visualize, we can see that the hand of the robot is basically located right here. So the next step that we want to do is basically place the gun near his hand, or at a location that makes sense. So we are going to push back spacebar to enter edit mode, and our gun should be located somewhere around 0, 0 right here. And I am going to disable that it is a sticky object, static object. And with the blaster selected, I am going to now select my camera, and I am going to basically create a parent-child relationship between the two. So blaster selected, camera selected, Control and R, and we can see that now we have a relationship. Selecting the blaster, I'm going to go in local space and zero that out to ensure that it is close enough to me. And like that, I can start manipulating it and place it plus or minus where I want it to be in space. If I push spacebar here to visualize, so we can have a better view somewhere around this location and a bit more up. We are in local space here, so somewhere here. And we want it to be visible at all time. That is going to give us good value to get started. We can later on tweak that to have better control. Basically, what we want is to have it on the side of the screen here, not fully aligned with the hand. Instead, it is going to be a bit too centered. We just want to give it a little offset here. Ensure that we're at 90 and 180 since we have been playing with that. And that should give us great value to get started. Now it is time to start coding the actual movement that will come from our keyboard and mouse, WASD, and the actual view control with our mouse.